Hello everyone, welcome to session 14 of LTEC 623 Digital Video Design. In this video, we're going to talk about research on learning and animation. Specifically, we'll delve into 4 dimensions of expository animation, and we'll close out by previewing the last 4 weeks of this semester. So let's get started. Now, I wanted to spend a little bit of time talking about animation because of its similarities to video in education. Now, we could actually spend a whole semester talking about learning with animation and how to design animation, but that's more than we can do in this semester. But I did want to give you a taste of some of the thinking and ideas out there related to educational research and animation. And so to do that, I want to summarize some of the findings by Plotzner and Lowe from their 2012 article titled A Systematic Characterization of Expository Animations. So here are some of their findings. They started out by arguing that animations are increasingly employed in education with the intention of enhancing students' understanding of complex processes and abstract concepts that involve change over space and change over time. Now, importantly, they argue that research on learning from animation is still in its infancy. The field itself actually has no systematic account of the main characteristics of expository animations. They go on to argue that one of the reasons for that is that there are so many different types of animations that it makes it difficult to compare the results from one study to another and to formulate valid generalizations across all of the different research studies. They also argue that the field itself lacks a systematic and comprehensive characterization of educational animations that could in turn provide a basis for guiding future development. So what they decided to do was actually research and focus on expository animations. And of course, expository means animations that are intended to explain or describe something. And they decided to only focus on animations that met some particular criteria. So let's take a look at those criteria. So the first one is the animations had to be computer-based. In other words, presented on a computer, not via a non-digital platform like a flip book. The second criteria is the animations had to have an expository purpose. In other words, they were intended to provide explicit explanations of the entities, structures, and processes involved in some subject matter. The third criteria is they had to have artificial creation. They had to consist of entities that were artificially created by drawing or modeling, in other words, not video. The fourth criteria is they had to be imitations. In other words, they were looking at animations that imitate processes to be learned via a sequence of varying images. This is really in contrast to simulation models that actually showcase or model processes computationally. So they weren't interested in simulations, just in expository animations designed to imitate some sort of processing. And they had to be pre-authored. In other words, the learner's task is to comprehend an existing animation authored by someone else. The learner is not setting out to create his or her own animation, which of course is a whole nother aspect of learning with animation. So that was the criteria they used to review. And they came up with a bunch of articles. They read those articles, they studied the videos used in those articles, and they came up with some findings. So importantly, they make a distinction, or they compare and contrast animation and video, which I think is particularly relevant to our course. Now, it's interesting, they frame video as relatively limited. Specifically, they talk about how video captures real-life entities, but that it's highly constrained with respect to what it can depict. It records visual information with a point-to-point correspondence, but it's limited by what is quote-unquote available to the camera during recording. And they criticize video because it misses material that is hidden from the camera, and it cannot introduce the explanatory abstractions that are characteristic of expository animations. In other words, video is fairly limited in its ability to depict hypothetical cases or present aspects of the subject matter that are non-visual. I think that's somewhat debatable. And it presents subject matter in a non-selective manner, although that can be ameliorated through the editing process by subdividing and editing different segments and perspectives of video together. Now, in comparison, these researchers argue that animation consists of artificially created entities, and there are some benefits to that. Specifically, animation could resemble video through very realistic rendering and treatment. It can depict nearly anything. If an animator can conceive of it, animation can depict it. Animation is far less constrained in how it can manipulate depiction of a subject matter. And obviously, it can take advantage of processes such as abstraction and visual spatial reorganization. It doesn't have to present reality. It has a broader spectrum of explanatory possibilities, and according to the authors, therefore, it has greater inherent flexibility as a representational approach compared to video. So that's kind of an interesting take on, or a side-by-side analysis of video versus animation. The bulk of this particular article focuses on 4 dimensions of animation. And the first dimension that they focus on is presentation. And presentation, of course, is about how animations represent subject matter to learners. So let's look at some of the subdimensions of presentation. One of the examples is what representations are actually employed in an animation. These can be visual, and they can vary in how image is used. And of course, animation can also include auditory information such as sound, speech, and/or narration. Secondly, animation differs in terms of abstraction. It can use iconic representations or abstract representations. So here's an example. This is actually from a simulation, but the picture on the left is showing iconic representations. So this is actually, it's a gas law simulation, and you can see the flames are showing, those are iconic representations of heat. Now, the picture on the right shows the same exact information, but it's really just using abstract or symbolic information. It's not using the iconic representations used in the left-hand interface. So that's an example of how animations can use abstraction differently. Now, another way that animations can differ in terms of their presentation is their explanatory focus. They can focus on the behavior of entities. They can focus on the structures that underlie the behaviors of entities, or they can focus on the functions that the behavior and structures fulfill. So those are 3 different explanatory foci. Here's an example of a brief animation showing a volcano erupting. And I would argue that this particular animation focuses on the structures that underlie the behaviors of an entity. In this case, the entity is the volcano, and its behavior is an eruption. So what are the structures that underlie the behavior of an eruption? So let's take a look at an example. Okay, great. So moving on, another subdimension of how animations present information is the viewer perspective. And of course, animations can show, just like video, single or multiple perspectives. Here's an example of an animation about seasons, and it's showing multiple perspectives of the same information. Another subdimension of how animations represent subject matter is the duration, the length of time over which the animation is presented. That can be very short or even up to 15 or 20 minutes. The 6th subdimension of how animations present information is categorized as spatial temporal arrangement. And this has a number of sub-dimensions, specifically spatial resolution, or the number of picture elements per unit of length. In other words, the degree of detail in the animation. We also have spatial structure, whether the animation is using 2 or 3 dimensions, and whether or not all of the entities have equal status on the display, or if they're arranged hierarchically with subordinate and superordinate entities. Here's an example of an animation about a tsunami, and it's using multiple perspectives. Of course, the presentation in an animation can vary in terms of its temporal resolution. In other words, the degree of transformation from one frame to the next. Think of this as frames per second. They can also vary in terms of how they represent time. And the authors argue there's actually 3 different categories here: time persistent, time implicit, and time singular. So here's an example of a time persistent animation, which visualizes the values of an earthquake and how the energy of the earthquake changes over time. Another important dimension is chronology, whether there is a linear course of events or a cyclical course of events. We also have concurrency, how many events are being shown simultaneously at the same time in the animation. And we also have the organization in the sense that events may occur equally in time, or they may be organized hierarchically by means of macro events and micro events. All of those subdimensions all fold up into the larger dimension of presentation. The second dimension is user control. User control is about the aspects of the animation that learners can manipulate. Now, importantly, user control is an external supplement to the animation itself. It doesn't have to do with the animation itself. And the authors found a couple of important ideas here. So first and foremost, you have timeline control, and they break that into temporal navigation and temporal scaling. Temporal navigation is the ability to start and restart the animation and to view specific segments of an animation. Temporal scaling, on the other hand, is the ability to modify the time of the animation itself, such as changing its speed. Another type of user control is presentation control. And this has to do with changing the appearance, varying the animation by magnifying the display or by changing the perspective of the subject matter. Another example of presentation control is actually modifying the information content of the animation, such as zooming in and out, showing or hiding visual layers, and turning narration on and off. Those are all examples of controlling information content. So here's an example from an animation called the Animated Atlas of African History. And you can see down in the lower right-hand corner, there are lots of user controls. The learner can turn on and off labels. They can manually move the timeline. They can jump to specific dates and times. They can enter a year, and or they can play the animation automatically at different speeds. So those are all examples of user control in animation. The third dimension is scaffolding, and scaffolding is any instructional technique used to move students towards stronger understanding and greater independence in the learning process. I know almost all of you are familiar with the concept of scaffolding in education. This is important when it comes to animation because learning from animation can be a challenging perceptual and cognitive process. There can be a lot to see and absorb, and a lot of information can be shown that needs to be processed cognitively. And designers may provide support to learners to help them cope with the demands of animation in the form of scaffolds. Now, scaffolds can be presented to learners visually or auditorily. So let's take a look at some examples. Using cues such as arrows and marks designed to guide the learner's visual attention. That's an example of a scaffold. Or using prompts such as questions and requests intended to facilitate the learner's cognitive and metacognitive processes is another example of a scaffold. So let's take a look here. This is an animation about how kidneys work, and you can see here that they have segmented the animation into discrete portions. We slowly kind of zoom in, but there is a lot of cueing. There's arrows labeling information and describing what specific visual aspects of the animation are designed to represent. That is all examples of scaffolding. The fourth and final dimension is configuration. And configuration is about the ways in which animation is made available to the learner. And this has to do with first execution. Does the animation just play once and then stop? Or does it repeat itself in a loop? So it plays all the way to the end and then starts over. And then most importantly is actually the setting in which the animation is encountered. Is the animation presented as a standalone resource, or is it embedded in a complex multimedia learning environment that may include additional static and dynamic representations, or include different representations presented to learners sequentially and or simultaneously? Here's an example of UC Berkeley's WISE interface. WISE is an online platform for designing, developing, and implementing science inquiry units. And what's interesting about it is it has a very simple user interface. It uses cognitive hints, embedded assessments, and online discussions with all kinds of tools for drawing, annotating, and it has lots of animations and simulations embedded in it. This is an example of using animation embedded in a complex multimedia learning environment. So that's a brief overview of the state of animation research. As you can see here, there's lots of dimensions to animation and lots of things that need to be considered when thinking about designing and or implementing animation for learning purposes. Finally, I want to close out briefly by just taking a look at the road ahead. So congratulations, everyone. We've made it to week 14. Your video project 2 is handed in. And this is going to be a nice, easy week for everyone because I want you to enjoy the Thanksgiving holiday. When you come back from the holiday, we're going to enter the final 3 weeks of the semester. And in week 15, we're going to kick off video project 3. I'm going to ask you to attend required office hours that week. So keep that in mind. I'll get those times posted as quickly as possible. In week 16, you're going to continue on video project 3. Keep in mind that the last day of instruction is Thursday, December 6th. And then finally, the very last week, finals week of the semester, you will hand in video project 3, which I will grade, and we will celebrate completing LTEC 623 digital video design. So that's a look at what's coming, folks. Thank you for your hard work on video project 2. I can't wait to take a look at them. Have a great week. Enjoy your holiday. I'll see you online.